This is adding and subtracting rational expressions. Alright, so we're going to go back to elementary school when you guys were adding and subtracting fractions. What was necessary on that was having what's called a common denominator. In this case, we have a common denominator. So what we do is we add the tops. So we get 12 over 16. And remember, just like in elementary school and when you guys were doing this first, you need to make sure you reduce it so the top is divisible by 4 along with the bottom. So you get 3 over 4, and that's your final answer. So it works the exact same with algebra. So you have to have a common denominator. So in this case, we have a common denominator already for us. It gets a lot more complicated when you do not have a common denominator, and we'll see that in a few. But all you do is, like I said, you can do a couple different things. You can just kind of add straight across if you want to, or you can write this as 5 plus x minus 5 all over x, and then simplify, so the 5's will actually end up canceling out. We're left with the x over x, and then you simplify from here again, and you get 1. This entire expression simplifies to 1. Alright, same order of business. We have a common denominator. So this one's slightly more complicated because you do have to make sure that when you're in algebra, you have the fully factored form. So I'm going to do the sort of shortcut method. So they already have the common denominator, so I'm going to add the top parts. So we have 5x minus 2. And the bottom part here ends up factoring into 3x plus 2 and x minus 1. Because the outer part is negative 3x, the inner part is 2x. That adds to give you the negative x, which is here. So we know that that is true. And the main reason we do that is because we're always looking for those married couples. We have no married couples here, so this is going to be your final answer. And don't forget also when it is asking for what your restrictions are, that's where the bottom equals 0, but here we're just simplifying. Okay, so slightly more complicated in this regard because now we're dealing with subtraction. Now there's a bunch of different ways of dealing with subtraction. What I like to do is I like to change the subtraction to a plus and change every one of the signs on top so that I don't have to deal with the distribution later. I take care of the distribution first. Since I have a like denominator already, common denominator, I can just add straight across. I got negative 2x. And then I've got my like term of 3 and negative 1, which gives me plus 2 all over. And this guy here, they are the same, but what I'm going to do is I'm going to factor it. So we got 2x minus 5, and we got x minus 1. And just to make sure, we got the outer part is negative 2x, inner part is negative 5x. That adds to give you negative 7x, which is what we want, and the signs of the inside the parentheses are the same. So that means that that is fully factored. Now, if you stopped and said, okay, that is your answer, you would actually end up getting this wrong, and here is why. You want to make sure that all the parts of your x have positive coefficients, and you also want to look for any GCFs as well. In this case, I see a GCF, and that the highest exponent is not a positive coefficient. So what I'm going to do is I'm going to factor out a negative 2. This is one of those hidden common factors. So I factor out a negative 2 and an x, that the 2 is taken out. The first part, the negative 2 is taken out, and this negative 2, when you take it out, becomes a negative 1. Remember, if you distribute it, you should get the exact same thing on top as what you started with, and we do in this case. So now we have 2x minus 5 on the bottom, and the x minus 1. And again, if you kept it just like this, you would have missed this common married couple right here that gets canceled out with the negative 2, and we have the 2x minus 5. And you can put this in parentheses if you'd like, but that is your fully factored answer. You want to make sure you check for anything that can be factored because you might have some married couples that are hidden. Alright, so how does it get slightly more complicated? Like I said, anytime you see the minus, it only affects that part. So for example, this minus becomes, changes the signs here, and I would like for people to scratch out any of the signs just so they don't get confused with that being a positive or a negative. And so now we can just add straight across. The 5x the negative 2x, that becomes 3x. I have the x squared, that becomes x squared. I'm also putting this in descending degree. And then we have the negative 11 and the negative 1, which gives you negative 12. And over here on the bottom, this is a difference of squares, and it has a common denominator, so we have x plus 2 and an x minus 2. Now, I told you to make sure that you have every one of the parts factored as much as they can, so you'd probably be trying to factor this, and if you tried, you would be unsuccessful because that actually is fully factored. It is a prime trinomial, so we just keep it as is. So that is your fully factored form, your fully simplified form. All right, and last but certainly not least, before we start getting into the more difficult stuff, so we have the minus sign here, so I changed that to a plus, change this sign, change this sign. I like to do that with a colored pencil or a marker, just like I did here, because I actually remember that I actually changed the sign. Now we have our like term set, so we have the 4x minus the x gives you the 3x, and then we have the positive 2, and then we have the bottom part here. It's a like denominator, which it always is for these first 6, and it'll change, but you want to make sure you check for that factored form. So what is the 3x squared minus x minus 2 factor into? Well, the two sets of parentheses, you would have 3x plus 2, and then the x minus 1, and again double check, you got negative 3x, positive 2x, which give you the negative x, and the whole thing foils out to be the trinomial part here, so we know that that's factored. And then we look for our married couples. We have a married couple here with the 3x plus 2, and once you cancel out everything, my advice, put a 1, just so you don't forget to put a 1, because a common mistake, what people will do is they'll cancel it out and they'll just say, oh, I'm left with an x minus 1. And they don't realize that the x minus 1 is actually on the bottom. So this would actually be incorrect. Please make sure you have that 1 that's up here to remind you that you have a 1, and then under it is the x minus 1. Okay, so now we're going to get into common denominators. Just like in elementary school, you had to find a common denominator. The way to think of a common denominator, let's say you have a type of person that you like, I don't know, just one of those things. Let's say it's a friend or something. I don't know. You can go into a lot of different things. But let's say we got one guy, Danny. He's blonde, he's smart, he's muscular, he's goofy. And then we got Matt, who is dark, smart, muscular, and sarcastic. If I asked what your type is, you would say, well, you're blonde, you're smart, you're muscular, you're goofy, but you're also looking for dark and sarcastic. So you're basically looking for all of these things, because we already have the smart, so we don't have to count him again. And we already have the muscular, so we don't have to count him again. So we're looking for these 6 properties. So we're looking for the common denominator in something. You're looking for all the parts that make up what that is, what that denominator should be. Okay, so here's another one, least common multiples. So we're looking for lowest common denominator, which means we're looking for the number that 16 and 24 both go into. Now, in terms of the whole numbers, there's a bunch of different ways of doing this. I'm going to do it a couple different ways just to show you. And what you can do is you can break it down into fully factored form prime numbers and do the common terms. That's the way we're going to do it algebraically. For example, 24, if you broke 24 down into its prime numbers, you have 6 and 4, 2 and 2, and 3 and 2. What you'd have is you'd have 3 times 2 to the 3rd power. 16 would break down into 4 and 4, 2 and 2, 2 and 2. So you'd have 2 to the 4th power. So what you're looking for is the separate entities. So for example, I've got a 2 to the 4th and a 2 to the 3rd. Again, think of this as the dark blonde hair, muscular type deal. You're looking for the highest exponent with that term. So I have a 2 to the 4th and a 2 to the 3rd. What they need is going to be a 2 to the 4th. And then the 3 is part of the 24. That means he's got to come along because it's the highest exponent of each one of the different parts. The highest exponent of the 2 is the 4. The highest exponent of the 3 is the 1, 3 to the first. So that's one way of thinking of it. And that's the way we're going to actually be doing it the algebraic way. Now, just to kind of show you, another way of doing this with whole numbers, but it's not going to really help out a ton in algebra, is to take the multiples of the highest number. For example, does 16 go into 24? No, it does not. But what you do is you take a multiple of that, so it would be 48. Does 16 go into 48? Yes, it does, 3 times. So 48 would be your lowest common denominator, which means look at 48 here, and then I'm going to backtrack and say, well, what is 3 times 2 to the 4th? Well, 3 times 2 to the 4th, if you do this in your calculator, it will give you 3 times 16, which is 48. And that's your common denominator. That's the thing that both of them go into. So that's a couple different ways of doing it. Okay, so I'm going to do, like I said, the multiples way is only good for whole numbers, but I'm going to do it the prime number way. So for example, this 15 breaks down to 3 times 5. The 12 breaks down to 2 squared times 3. You want to take the highest powers of each one. So I have 2 squared. I don't have any 2 in the other one, so that means the highest power of the 2 squared is 2 squared. We have the 3, and the 3, the highest power of that 3 is, well, 3 to the first. And then we have the 5, and the highest power of the 5 is 5 to the first. So if you multiply these, you get 4 times 3 times 5, 12 times 5, which is 60. So the common denominator of this would be 60. Would be 60. And again, if you wanted to do it in terms of the multiples, you could. The multiple of 15 would be 30. 12 does not go into 30, so you go to the next one. 45. 12 does not go into 45, so you go to the next one. 60. 12 goes into 60. Yes, it does. So that means the number that both of them go into is 60. But the way, again, we're going to be doing it is by the common or the numbers with the highest exponents, each one of the numbers with the highest exponents. Okay, what about algebraically? So let's say we had 2 expressions here. So you look for each one of the parts. So I see I have an x and I have an x. The highest exponent of that x is x to the first, right? There's nothing different. We have an x minus 2 here, and we have an x minus 2 and an x minus 2, which means that part actually is x minus 2 quantities squared. So this, actually, the highest exponent between the x minus 2 and the x minus 2 quantity squared is x minus 2 quantity squared. For the last couple, we have x plus 3 and an x plus 3. The highest exponent I see is just an x plus 3. And then we have an x minus 5. We don't have another one of the x minus 5 in the other part, so we have just an x minus 5. That's the highest exponent that you see. And then last but certainly not least, you have the x minus 1. So the x minus 1 is another part of this long and complicated lowest common denominator. You're never going to get something this complicated in a standard Algebra 2 class, but just we're looking for commons and the highest exponent of each one of the parts. Guys, if you want to pause the video and try this on your own, you can do that, or I'm just going to kind of go through it and do the different parts. So 20 and 5. The number that both of those go into is 20. And again, you can break it down, and you have the 2 squared. And the 5, the highest exponent of 2 squared from both of them is 2 squared. So you got 2 squared. And then the highest exponent of 5 is 5. 2 squared times 5 gives you 20. So that part is done. So now we deal with the algebraic terms. So we have the x minus 2. We don't have any x minus 2, so that is the highest exponent of that particular part. We have the x plus 5. We have an x plus 5 in this other part. The highest exponent of each one of them is just 1, so you only have 1. And last but certainly not least, you have the x minus 1. He doesn't have another part, so the highest exponent that you see of that one is an x minus 1. That would be your common denominator, your common multiple of the algebraic expression. So where does this actually come into play? I'm going to just kind of jump in with this one right here. So the least common multiple is what you're doing is you're looking at algebraic fractions, what's called rational expressions. And the reason they're rational is because you have a number over another number. But we have two exponents here. We have an x plus 4 and an x, just an x. So you take the highest exponent of each one of those parts. So the highest exponent of x plus 4 that I see, well, there's only one x plus 4, so it's just x plus 4. So that one's taken care of. The highest exponent of x that I see is x, so now that one's taken care of. So the lowest common multiple of that denominator would be x and an x plus 4. And again, you need to know the lowest common denominators for fractions or rational expressions because you're going to be adding them. All right, for this next one, this is why you have to kind of know your factoring terms. So x minus 3 is x minus 3. He's not really that complicated, but the 3x minus 9, well, I can factor out a 3 from this and get x minus 3. So I have an x minus 3 that I'm going to deal with first. I have the x minus 3 and the x minus 3 here. The highest exponent that I see of that is an x minus 3. I have a 3, and that's the highest exponent that I see of each one of them. So that means this common denominator would be 3 times x minus 3. Done. And the last couple, it happens to be that one of the parts carries, well, in this part, one of the actual expressions carries the entire common denominator. That can happen sometimes. All right, so how does this get slightly more complicated? Well, let's see. We've got the 3x plus 1 as one of the denominators, so he's already factored. We're going to factor this guy right here. He actually becomes 3x plus 1, and then an x minus 1. So now we're looking for the highest power or highest exponent of each binomial expression. So when I say binomial expression, we have the 3x plus 1 and the 3x plus 1. The highest exponent that I see of each one of those is just to the first power, so it's 3x plus 1. So that's one part. We can cross it off as we go if it helps you. Like I said, just to find the denominators. And then after that, the x minus 1 here does not have a partner. Don't think of it in terms of a partner, but another part that you look at because he just kind of comes along for the ride because he's the highest exponent. So the common denominator here would be 3x plus 1 and x minus 1. All right, so why did we actually do that? Because, okay. Why do we actually do that? Because now we're going to actually add these. And this is why you need to know the common denominators. So I'm looking at this. I have 4 and I have 8. You cannot just say that this expression is going to give you 5x over 12. And if you do that and you say, yay, I'm done, you are WRONG with 18 exclamation points. Actually, let's put a frowny face. That kind of looks weird, but you get the idea. The main thing is that you have to think algebraically that you cannot just add the exponents or add the expressions on top and bottom. You have to do a little bit more. So what I'm going to do is I'm going to find the LCM, lowest common multiple, or the LCD. You can also refer to it as the lowest common denominator. So we have two parts here. We have a 4. We have an 8. Since this is a number, we can actually just ask ourselves, what is the number that 4 and 8 both go into? Well, 4 goes into 8, so that means 8 is my lowest common denominator. Now, what did you have to do when the denominators were not the same in elementary school? Well, you had to simplify and make sure that one of these things does not look like the other. So that 4 does not look like an 8. It's not an 8, so we need to make him an 8. What do we multiply the top and bottom of this expression by to get that denominator to be an 8? Well, what is the 4 missing? Well, you have to times that by 2 in order to get 8, so that means it's missing a 2 out of the factor. So we have multiply the top by 4x, it gives you 4x, the bottom gives you 8, plus 3x over 8. So that gives you 7x over 8. Again, the other way of thinking of this is break down the 4 into 2 squared, break down the 8 into 2 to the third. Well, what's the highest exponent that you see? Well, it's 2 to the third. And then you ask yourself, what is each one of the denominators missing? The 4 is missing one of these 2's, so you have to multiply the top and bottom by 2. Because what you do to the top, you have to do to the bottom, because it's basically like multiplying the problem by 1. This one's not missing anything, so he stays the same. That's why you get the denominator as 8, and your final expression answer is going to be 7x over 8. So this is your final answer. Okay, how does this get more complicated? Well, here we go. Again, you have to ask yourself what your denominators are. So I've got a 3x and I've got an x squared. So what I like to do is I like to put the 3x and then the x squared over here, and I split it up into different parts. So the first part is the variable x. So I have an x and an x squared. What is the highest exponent of the x and the x squared? Well, it's x squared. And then you have to ask yourself, what's the next part you deal with? Well, we have 3. So 3 is the only existence of 3, so that means he has to be part of that denominator. So that means that that is your LCM, your lowest common multiple or your lowest common denominator as well. Then you ask yourself, what is the 3x missing from this 3x squared? Well, he has an x, he has a 3, but he does not have one more x. So you need to multiply that top and bottom by x. So if I do that, I multiply the top and bottom by x, I get 6x over 3x squared. When you do that, the denominator should always be what your lowest common multiple is, or what your lowest common denominator is, namely over here. And now do the exact same thing with the second expression. Well, we have an x squared. What are you missing from the LCM? Well, I'm missing a 3, so that means I'm going to multiply the top and bottom by 3. So that gives me a minus and a 27 up top, and the bottom part becomes 3x squared. Now, I have common denominators, 3x squared and 3x squared. Now I can add them. I cannot just say 6 minus 9 is 3, and then I have over 3x minus x squared. If you do that, you're going to get every single one of these wrong. You have to make sure you have a common denominator. In this case, we do. Now we can add, or subtract in this case, 6x minus 27 all over 3x, quantity squared. So what that means, not quantity squared, sorry, 3x squared. What that means is that if you did this and said that's your answer, you would still get this wrong. Because you have to check and make sure that every part is factored. The bottom part is already factored. So that's not a problem. The problem is the top has something that can be factored, and that's a GCF. It has a GCF of 3. So 3 times 2 gives you 6, and 3 times 9 gives you 27, which means they have a 3 in common. So if I factor out a 3, I'm left with a 2x, and I'm left with a 9. The minus sign comes along for the ride, and I'm left with a 3x squared. Then you look for what can cancel. And the married couples can cancel. Well, the 3 is kind of a singular married couple, I guess. So singles, they cancel out because their numbers, numerical values, can cancel out, which means that is your final answer of 2x minus 9 is binomial over x squared. Finished. That's your answer. Okay, and slightly more complicated yet again. So now we have 2 different binomials in this case. So I have an x plus 7 and an x minus 3. You'll get quicker at these once you start practicing these. So we have an x minus 7 as one of the denominators, and we have an x plus 3, or an x minus 3 as one of the denominators. Well, the nice thing is that we don't have anything in terms of common exponents or common binomials or anything like that, so we can just take one from each. So the highest exponent of x plus 7 is x plus 7 to the first. And the highest exponent of x minus 3 is x minus 3. So this is your common denominator. Then you ask yourself, what is this missing from the common denominator? Well, it's missing an x minus 3, which means you have to multiply each one of these by x minus 3. Okay, and I would put these in parentheses. Anytime you have binomials, put them in parentheses, just because it's going to make your life a little bit easier down the road. And then you do the exact same thing with the other part of x minus 3. What is he missing? Well, x minus 3 is missing the x plus 7 from the LCM. So x plus 7, parenthesis, x plus 7, parenthesis. So now what I have to do is I write my common denominator, which is x minus 3. Don't FOIL it out because you're going to be going backwards if you do that. Just keep it in the factored form because you're going to be looking for married couples later on. This part you want to FOIL out because we have a minus sign we have to take care of here. The bottom number is already multiplied. So I'm going to distribute. I get 8x minus 24. And this I can change to a positive, keep that as a negative. So I distribute the negative 5 to each one of them. I get negative 5x and minus 35. Once I do that, I need to simplify the top. So my like term set with the top is 8x and minus 5x, which gives me the positive 3x. And then I've got the negative 24 and the negative 35 give me negative 59, all over the factored form of binomial x minus 3, x plus 7. That, because 3x minus 59 does not have a common GCF, you can't factor them out, nothing cancels out, you are done. So that is your fully factored form. And don't, I'm telling you, do not FOIL that out. Don't put that back into a trinomial form because, again, that does not mean it's fully simplified. Okay, if you want to pause the video and try this one on your own, you're more than welcome to. I'm going to go ahead and do this one for you. So we have a 5x plus 2 as one of my denominators, and I have a 5x plus 6. Now what I want to do is I want to factor the 5x plus 6. So I see that I have a 3, that is a GCF, and I have a 5x plus 2 that is left. So I have the 5x plus 2, and then I have a 3 times the 5x plus 2. So those are my two denominator parts. And then you ask yourself, what's the highest exponent of each part that you see? 5x plus 2, 5x plus 2. The highest exponent that I see of that is a first power. So that means I have a 5x plus 2. So that's 1. And then I have a 3, and he's the highest exponent that I see. So I just have a 3 in front of that. So the LCM, the common denominator, ended up being this part right here, which is cool. So the minus 4 over the 15x plus 2 does not need anything. But this part here is missing something from the LCM. And what it's missing is the 3. So I have to multiply the top and bottom of this expression by 3. So I'll get a 3x on top over 3 times 5x plus 2. And then I have a minus and a 4, minus 4. So here is my fully factored form, if you want to put that in parentheses. The top does not have a GCF. The bottom already has the GCF factored out. You already took care of the common denominator, so that one is done. All right, and next we have, again, an x plus 2 as one of my denominators. So we have x plus 2. And then we have the x squared plus 4x plus 4. You want to factor that. See if it does factor. In this case, it does factor into x plus 2 and x plus 2, which can be rewritten as x plus 2 quantities squared. So we have a common denominator that kind of pops out at me. When you get good at these, you can start to do that. But the x plus 2 is one of them, and the x plus 2 quantity squared is another one. The highest exponent of that x plus 2 is the x plus 2 quantity squared. So now you have to ask yourself, which one is, for the first one, what's it missing? Well, it has an x plus 2, but it needs another x plus 2 from that common denominator, because this has 2 of them. So that means, when you do that, you have the x plus 2 and the x plus 2 on the top and bottom, and I would put the binomials in parentheses just to kind of remind you to do that. So the bottom, you don't factor, or you don't FOIL out, so keep it as x plus 2 times x plus 2 or x plus 2 quantity squared. Actually, to make it easier for you guys, what I'm going to do is I'm going to put x plus 2 times x plus 2. You'll see why in a few seconds. And then the top, you have to FOIL out. So we have first outside, inside, last. We have x squared minus 4x because it's a difference of squares. And then we have the plus x minus 2. And now you look for common like terms, and with the like term, I have x squared is alone. We have the plus x, because I'm doing it in descending degree. The negative 4 and the negative 2 become negative 6, and you're left with x plus 2. and x plus 2. Now, if you kept it like this and said, yay, I'm done, you would actually end up getting this mostly right, because it does factor, the top does factor, but you want to make sure that everything is in factored form. So the top actually is a trinomial that factors into x plus 3 times x minus 2 all over x plus 2 times x plus 2. You look for your married couples. We don't have any married couples here. These are not a married couple, so you do not cancel those out because the minus 2 and the plus 2 are different signs. They are not the exact same, so they are not a married couple. So your final answer is this here. If you put this, like I said, you're 90% of the way correct, but you need to make sure that it is in fully factored form. Okay, and moving right along, so I got my factored form here. I'm going to go a little bit quicker with this one, x plus 3 and x plus 1. So that's my factored form of this trinomial. What some people like to do is they like to go, okay, I'm done here, so I don't even have to look at this, and they cross it out completely, and that is completely fine, and then you look at your common denominator. So you have an x plus 3, have an x plus 1, and then we have an x plus 3. Highest exponent of each one of these binomials. So the highest exponent of the x plus 3 is just an x plus 3 to the first power. Highest exponent of the x plus 1 is just an x plus 1 to the first power. We're now looking for common, what they have in common. We're looking for the highest exponent of each part. Remember that the type example. It did not have the things in common. It was looking for all the different properties that it had total. So, and the highest amount of each property. So now, the first part here, already x plus 2 over x plus 3 and times x plus 1. That does not need anything from this common denominator, but the minus 6 does. He needs, and I'm going to put this in parentheses, an x plus 1 on the top and the bottom. So x plus 1. And again, if it helps, you can change this to a positive sign and this to a negative because you're going to use distributive property. So that means I'm going to change that to a positive, and I have the negative 6x minus 6. If you're one of those ones that was like, okay, I've got the common denominator, you can, like I said, rewrite it like this and then combine them, or if you want to skip that step of rewriting it like this and then combining them, you can skip that middle step and just combine them. And that's completely fine when you get pretty quick with these for the most part. But after we have this, then we have to collect the like terms on the top. So I have my 6x, negative 6x, and the positive x become negative 5x. We have the 2 and the negative 6 become negative 4. And the bottom term becomes x plus 3 and x plus 1. And you are done with this one. There's no GCF on the top. There's no married couples that cancel out. So that is your fully factored form and simplified form.